Okay, as I mentioned at the end of the last video, I told you we would start into equations in this particular section. And I told you that one of the differences between an algebra equation and an algebra expression is an algebra equation has an equal sign in it. There's other differences, as you'll see in just a minute as well, but let me begin by showing you this. If I have x plus 3 plus 8. This right here is an algebra expression. This is very similar to what we did in the very last section. And so what I can do is I can simplify this by saying x 3 plus 8 is plus 11, but that's as far as I can go with that, because I can't add that variable term together with that number term. But let's suppose I have x plus 3 equals 8. Now, this is a very different problem, because what this is an algebra equation because of the equal sign. One of the main differences between an equation and an expression is this. In an equation, we try to find the number that we could put in x's place that would make this thing be true. When we find the number that we could put in x's place that would make this be true, we call that the solution to the problem, or we call that solving the equation. You can't solve an expression. For instance, let's suppose I cover this up. Let's suppose I told you, okay, I'm thinking of a number, and I'm not going to tell you what it is. All right, I'm going to add 3 to my number. Now I'm going to add 8 more to my number. What was my original number? Well, you have no way of knowing. I said, I'm thinking of a number, I'm going to add 3, then I'm going to add 8 more. What number did I start out with? You have no clue. But look at this one. This says I'm thinking of a number, I'm going to add 3 to that number. And when I do, I get 8. What's that number? Well, what plus 3 would give you 8? Of course, that means the answer here would have to be 5. So if I let x be 5, that is the solution to that problem, because 5 plus 3 is 8. As a matter of fact, not only is that the solution to the problem, it is the only solution to that problem. Nothing else you could put in for x that would make that be true. So this is what we call solving the equation. We simplify expressions, we solve equations. Now, whenever we solve an equation in mathematics, there are some equations in mathematics that have one answer. There's some that have 2 answers. There's some that have 3 answers, etc. There are also some equations in mathematics where everything works. We say that it has infinitely many solutions. Any number you plug into that problem makes it work. I will show you one of those in just a few minutes. But there's also some problems in mathematics that has no solution. We call those contradiction equations. But what we're going to do right now is concentrate on solutions just for right now that have one solution. Now, why do we need to learn a mathematical process to solve equations? Because not all equations are as simple as this. Sometimes the equation can be extremely long. And so I can't figure those out in my head. So I need a mathematical process to do that. So what we do, instead of diving off into those really, really difficult problems, what we do is we start with the simple problems, and we go from there and learn how to solve the simple problems. And then when we get to the more complicated problems, then we're able to deal with those. Get me another pen out here. Okay, so what is the process of how we go from here to here mathematically? Well, the goal to solving the equations that we're going to be looking at is where we want to get the variable term on one side and we want to get the number term on the other. Once you get that variable term on a side by itself and the number term on the other side, the problem is then solved. So our objective is for our bottom line to be x equal 8, or x equal negative 7, Or it may say 7 equal x. That's the same thing as x equals 7. So it doesn't matter if this says x equal 5 or 5 equal x. So our objective is to get the variable terms on one side and the number terms on the other. Now, another reason you want to get the variable terms on one side of the equal and the numbers terms on the other side of the equal is because you can't add them together until they're on the same side. See, we learned in the last section, you can't add variable terms and number terms together. But you can add variable terms with variable terms. So the question is, if we have number term on one side of the equal and another number term on the other side of the equal, how do we get them on the same side? Well, we'll deal with that in just a minute. Before I do that, let me remind you of something probably that you've heard since 6th or 7th grade algebra or pre-algebra in school, and it's this. It's what I call the golden rule to equations. And it's simply this. Anytime two things are equal, as long as whatever you do to one side of that equal, as long as you do it to the other, they're still equal. For instance, if I have two things that are equal and I add 7 of them over here, they're not equal anymore. But they are if I add 7 over here. And so what we do is that's the idea, is we add and subtract things, but we do it to both sides in order to arrive at what we want to arrive at. So, for instance, if I had adding 3 on the left side and I didn't want it there, what I would do is I would say to get rid of the adding 3, we will subtract 3 from the left side. Because the adding 3 and the subtracting 3 adds to 0. But if I subtract 3 from the left side, I have to subtract 3 from the right side. Same way if I want to get rid of a subtracting 2x, I would plus 2x to that side. But whatever you do to one side, you have to do the other. And I'll show you as we go along. We'll work a bunch of examples, and I think you'll kind of get the hang of it as we go through. So let's start out, and the instructions here to these problems now will be solve. Anytime you see the word solve in mathematics, that means the problems that you're about to work with will all have equal signs in them. So let's start out, and let's look at solving some problems. So let's start out with the very one that I just wrote up. Now, one of the things I want to encourage you to do is this, for right now, particularly while you're going through this with me. Don't take any shortcuts. I mean, you work it just like I work it until you really get the pattern. Now, if you've got your own little way of doing things, as long as you're getting to the solution, I'm okay with you not doing it exactly the way that I do. But for those of us that algebra is not our thing and we're really starting at ground zero, I really would suggest that you put in all these steps initially while we're going through. Okay, so if you'll look at this problem, you have a variable term, a number term, and a number term. You want these two number terms on the same side, but you don't want them on the same side as the variable term. So I want to get rid of this adding 3. So the way I get rid of this adding 3 is by subtracting 3. You'll see me do that in red. Now, when I subtract 3, you will also see then that I will subtract 3 from the right side. So you can clearly see here what I've done in red. I have done the same thing to both sides. Now, on the left side, the 3's add out. They don't cancel. The word cancel is a word that we use when we're dividing. Add out means it goes to 0. Plus 3 minus 3 adds out. So this leaves x equal, and then 8 minus 3 equals 5. And that is the solution, which we already knew, because 5 plus 3 is equal to 8. So that can easily be checked. Okay, let's do another example. So let's suppose I have x minus 3 equals 8. All right, I want to get the x's on one side. I want to get the numbers on the other. So now what I want to do is I want to get rid of this subtracting 3. I want it gone. I don't want it on this side. So to get rid of a subtracting 3 To add it out, you'd have to add 3. But whatever you do to one side, you have to do to the other. Now, the 3's add out, and that just leaves x, and that would leave x equal 11. And you'll see, if you take 11 and plug it back in, 11 minus 3 is equal to 8. All right, let's do another. So let's suppose I have x plus 4 equal to negative 5. X plus 4 equal negative 5. So to get the x by itself, I would have to, this is adding 4. So to undo the adding 4, I subtract 4. And one of the ways you can tell if you've done it right is if these numbers don't add out, you're not doing the right process. But whatever I do to one side, I must do to the other. So the 4's add out, and I'm left with x equal. Now, here we are again, back to what we did in the very first lecture video. If you lose 5, and then you lose 4 more, you have lost 9. So the answer to this is negative 9. All right, let's check it. Now, we're not going to always check these, but I just want to show you. If I let x be negative 9, if you lose 9, but then you win 4 back, you are at down 5. So that is the solution to the problem. All right, now, let's suppose that the x is on the right side. Well, if the x is on the right side, and that's the only x in the problem, I'm just going to leave it right there and get the number terms on the left side. So what do I need to do in order for that to happen? Well, if I'm going to leave the x on the right side, I have to get rid of that subtracting 6. So to get rid of the subtracting 6, I will have to add 6. But if I add 6 to the right side, I must also add 6 to the left side. And when I do, I get 14 equals to x. All right, let's do another one. All right, 9 is equal to 9 plus x. Okay, now what I want to do here is, I got one variable term and 2 number terms. Now we're going to make some longer ones in a minute. I'm just wanting you to learn the process. So what I want to do is I want to get the variable term by itself. So I want to get rid of this 9. Now this is 9 plus x, not 9 times x. We'll talk about that in a few minutes as well. So I want to get rid of this 9 right here. It's not part of the variable term. So to get rid of this 9 here, I'm going to have to minus a 9. Because 9 minus 9 adds out to 0. But if I do that to the right side, if I subtract 9, then I have to do the same thing to the left side. So 9 minus 9 here adds to 0. And then over here the 9's add to 0, but I don't have to put the 0 because there's still an x over there. Now you do have to put 0 on the left side. So the answer to this is 0. And you can clearly see that because 9 plus 0 is 9. Okay, now let's change it up just a little bit. Well, let me work this one, then I'll work the next one I want to work. 5 plus x equals 20. Okay, so I want to get rid of this 5. Now, how do I get rid of that 5? Well, this is adding 5, so what I'm going to do is subtract 5 from both sides. When I do, the 5's add out, and so that leaves me with x equals 15. Now, let's work another one that's different now, that looks real similar to this one right here that I just worked. Except this time, I want to work 5x equals 20. Now, this now is not 5 plus x, it's 5 times x. So let's suppose I tried to get rid of this 5 the same way I did in the last problem. So let's suppose I thought, okay, to get rid of this 5, I have to subtract it. Watch what happens. If you subtract 5 from both sides, this doesn't subtract out because this is 5x. This is not 5 plus x. So that won't work. And the reason that won't work is this. This problem right here is 5 times x, not 5 plus x. 5 times x. Just a second, I'm trying to figure out how that's turning. There we go. Okay, so I have 5x equals 20. Now, to get rid of this x, since this is just like if I want to get rid of an adding 5, I subtract 5. To get rid of a subtracting 5, you add 5. Well, this is a multiplying 5. 5 times x. So the way we get rid of this 5, to undo multiplication, you divide. But whatever you do to one side, you have to do to the other. So now the 5's cancel. Now there I use the word cancel, because when it cancels, it leaves 1x. So 5 goes into 5 one time. I don't have to put that in x equals 4. Now let's see if that's correct. If you let x be 4, what is 5 times 4? Of course it's 20. So that is the correct solution to that problem. So as you will see in the next few examples, if you have a number in front of the x, directly in front of it, remember we gave that a special name called the coefficient of x. The way you get rid of the number that is in front of x, coefficient, is simply by dividing to undo that multiplication. Now don't confuse that with this. Is this 5 in front of the x? Yes, it is, but it's not directly in front of it. It's not the coefficient of x. Here it is. Okay, so if I have something like this, 7x equals 28. 7 times x. So you don't get rid of this 7 by adding or by subtracting. You get rid of it by dividing. And when I do, whatever I do to one side, I have to do to the other. Now, the rules about dividing, you're still going to run into those. They're still in play. So if you have 6x equals negative 30. 6 times x, so you divide to get rid of that 6. So you get x equals to a negative divided by a positive is a negative, and 30 goes into 6 5 times. Now, when you divide these, they don't have to divide out evenly. So let's look at this one. So let's suppose I have negative 8 times x, not plus, equals negative 11. How do I get rid of that negative 8 that is multiplying that x? By dividing. And whatever I do to one side, I have to do to the other. The negative 8's cancel, leaves a 1. A negative over a negative is a positive. And then 11 over 8 does not reduce. So that is the answer to the problem. Now, if I have this, negative 4x equals 0. Remember, the goal is to get the x by itself. So I got to get rid of this negative 4, but it's multiplying that x. To get rid of that negative 4 times x, you divide by the negative 4. Now, you don't divide by the x also. You divide just by the coefficient. But whatever you do to one side, you have to do to the other. These cancel, and then this would be just 0. Where did that come from? Remember we learned in the last section, 0 divided by any number is still just 0. Now, what happens if there is a 0 in front of that x? Like this. Well, remember we said a while ago, in mathematics, we can never divide by 0. So, if I do this, what's going to happen? Any number divided by 0 is undefined. There's no answer to this problem. So what we say in this case is, the answer is no solution to that problem. We'll talk a little bit more about that in the next section. Okay, so that's about as far as I wanted to take this video. It's 20 minutes long, so I'll stop and pick up with the next, still in the same section, but pick up with the problems I've left off here.